All right, here's lesson 10, non-perfect squares. So most numbers, in fact, are not perfect squares. We've been dealing with, the first 10, 12 perfect squares. So 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So those are the first couple perfect squares. But in fact, there's a whole bunch of numbers in between. 2 and 3, and then we've got 5, 6, 7, 8 that fit in there, and then we've got 10, 11, 12, 13, 14, 15 that fit in there, etc., etc. So there's actually a ton of numbers that are not perfect squares. For most numbers have square roots that are irrational, so non-terminating, non-repeating. So for example, the square root of 8. If you take 8 and find the square root, 2.82842, etc. Okay, so 2.8284, etc., etc. The root of 115 is 10.7238. Now these are actually called principal square roots. These are the positive versions of the square roots. There is negative square roots, but we're not going to really dwell on those. So 4.5, the square root is 2.12. Keeps going. 293 is 17.117. Now while I'm doing these, I would encourage you to pause the video and try these on your calculator. So the root of 2. 1.41421, etc., etc. And the root of 301 is going to be 17.349, ... And the other day we kind of talked about, using our benchmarkings. So the benchmarks, for example, the root of 100 is 10, and the root of 121 is 11. So if we were to do something like 115, well, that appears to be right, kind of in between. And the answer to it, or the simplified version, is also in between the two roots of those numbers. So when we work with square roots, if the numbers are all included underneath one root symbol, you can simplify that to just one square root, the root of 9. And if we actually find the square root, we get positive 3. If the two numbers are separated by a positive or negative, you cannot just combine these, root 9. And I'll show you why. If you do this, root 4 plus the root of 5 gives us 2.23, okay? And if you do those separately, so 2 plus 2.236 ... Our answer is 4.23, which is much different than what we just had in 3. If there's a number and a root kind of multiplied, evaluate the root. So we end up with 4, and the square root of 25 is 5. Well, what's 4 times 5? 20. So our answer is 20. And the last one, if we have a mixed bag, do your square roots. Remember BEDMAS. Square roots fit under the exponents part of it. So if you evaluate the square root of 4, that's 2. And if you evaluate the square root of 36, that's 6. So 7 multiplied by 2 is 14. And 3 multiplied by 6 is 18. And 14 plus 18 gives us 32. Awesome. So let's do some PAT questions. And not only to practice the square roots, but also to practice filling in the scantrons. So when a square piece of paper is folded in half, the resulting figure has a perimeter of 24. So it's folded in half, and the resulting perimeter is 24. So we had some piece of paper, Okay, and if it was square, and now it's not square. Okay, so if you were to, think of half of the square as like x, and this is x, well, the entire length would be 2x. Okay, and this part would be x, and this is x, and then this is also 2x. So we're dealing with half the paper. So our perimeter is going to be 2x and 2x and x and x. Okay? If that piece of paper is actually folded, the diagram would look more like this. This side would be twice as big as that side. So that's where the 2x comes from, because it's twice as big. So in total, we've got 2x, 4x, 5x, 6x. We've got 6x is equal to 24. And if you divide by 6, x, I'm doing it very poorly here. Let's give myself some more room. So 6x equals 24. If you divide by 6, x is equal to 4. All right, so now that we've got what x is equal to, you can plug that back into the original diagram that we have. So 2 times 4, and 2 times 4, 2 times 4, and 2 times 4. So our actual original square has dimensions of 8 and 8. So what's the area there? Well, 8 multiplied by 8 gives us 64 centimeters squared. That's probably a level of excellence question. It's pretty tricky. Kind of have to think through the entire problem. Here we go. What is the value of, well, this is a numerical response question, so this one would be on the non-calculator portion of the exam. So we got to do a whole bunch of figuring here. 0.4 divided by 2 minus the root of 9 over 36 multiplied by 1 1/5. So let's start with this root of 9 over 36. Now, that part is tricky, but if you think of just like, what's the square root of 9? Well, the root of 9 is 3. And what's the square root of 36? Square root of 36 is 6. So let's reduce this to 3 over 36. And then I'm going to change 1 1/5 to 6 over 5. And everything else, I'm going to 0.4. Okay, so 0.4 divided by 2 minus 3 over 6 multiplied by 6 over 5. Let's do the 0.4 divided by 2 first. So 0.4 divided by 2 is 0.2. And we're going to subtract 3/6 multiplied by 6 over 5. So 0.2 minus 18 over 30. And 0.2, 18 over 30 is, let's divide that by 2, so 9/15. And if you divide by 3, you're going to get 3/5. Okay. And 0.2 minus 3 over 5. You could answer this either in decimal. Does it say the area? What is the value of? Okay. So I'm assuming decimal or fractional form would work. So if you want to do decimal, this is going to be 0.2 minus 0.6, which is negative 0.4. And if you wanted to leave it in fractional form, 0.2 is the same as 2/10 minus 3/5. So 1/5 minus 3/5 gives us negative 2/5. So you could answer this in two ways. You could do negative 0.4. That would be acceptable. Or if you wanted to use the fractional form, you could do negative 2 over divided by 5. So that would also be acceptable. Now the PAT question, multiple choice, so probably on the calculator section. The approximate root of 15 is represented by the letter. All right, well, number lines, square roots, you need to kind of connect what these numbers are. So this would be the root of 4, this is the root of 9, the root of 16, and the root of 25. Well, 15 is pretty close to 16, isn't it? So that's got to be letter L. And then we've got this assignment. Let me just talk about rooting fractions. Okay, these fractions. They're always going to be if you simplify the stuff first, you can kind of look and find the same sort of patterns in perfect squares and stuff like that that we've been seeing before. So the square root of 49, if you did that part first, you'd get 7. And then if you followed that up by the root of 100, that's going to be 10. So the answer is 7/10. Because if you multiply two fractions, 7/10, you're going to get back to that same fraction. So all these questions have a similar pattern. Okay, well, what's the square root of 64? Well, that's 8. And what's the square root of 121? That's 11. That's your answer. The square root of 16 over 25, well, do the root of 16. That's 4. And do the root of 25. And that's 5. So my answer is 4/5. And all of these you can check. 4/5 multiplied by 4/5 gives me 16 over 25. That's what I started with. Sometimes you can't do it. 27 over 3. Well, the square root of 27, that's not a perfect square. But if you simplify this first, you're going to get root 9. And root 9 is an easy one to do. That's just 3. Okay? So with these fraction square roots, look for those same common patterns and do the square roots of like the perfect squares, because they are there, they're just a little bit hidden. So the root of 9 over the root of 16, root of 12 over 3. Those aren't perfect squares, but what happens if you simplify that? You get the square root of 4, and that one you can do.